Hello students, today I am here with another topic, that is resultant by resolution. So today we are going to discuss how to find out the resultant force from different forces by resolving it. As you know that there are different methods to find out resultant. First method is a graphical method. In that we can use triangle law to find the resultant, and second method in graphical one is polygon law of forces. We are going to use polygon law. So triangle law and polygon law, these are two are the graphical methods to find resultant. And second one, there are analytical methods. So there are two methods. First one is resolving the forces into components, and second one is law of parallelogram, that is non-perpendicular resolution. Okay. In non-perpendicular resolution, again there are two types. First one is by using law of parallelogram. Second one is using skew resolution. But today's topic of interest is resultant by resolution of forces. Now just look at this. So first of all, what is meant by resolution? Resolve means what? Split up into component or resolve into component. So it is the method by which a given force is split up into two or more components without changing its effect on the body is called as a resolution. Okay, means it is also called as breaking a given force into component or replacement of a single force by its several components, which is equivalent an action to that of given force, that is called as the resolution of forces. As I mentioned before, there are two types. First one is a rectangular components or rectangular resolution. That is also called as orthogonal resolution or perpendicular resolution. Means here any force F, suppose force F is there, this particular force is resolved into two components, X and Y, that is called as a mutually perpendicular component, or that is called as a rectangular component. Rectangular means what? In X direction one component will be there, in Y direction will be there as another component, and considering angle theta. In this force F, if this is the force F, it can be resolved into two components. In X direction it will be F cos of theta, in Y direction it will be F sin of theta. So that is called as a rectangular component resolution. Second is a non-orthogonal or non-perpendicular, that is called as the law of parallelogram. I think already we have discussed about it. Now first of all we are going to just concentrate on resolution. So given force F, as already I have explained it. So given force F, you have to resolve into X direction, you have to resolve into Y direction. So component X component or horizontal component. X component means what? In this direction, or horizontal component Fx. Here suffix X is for X direction. So component of this F in X direction, it will be Fx will be equal to this F cos of theta. This angle is theta. Okay. So in X direction, if you want to resolve, you take cos theta. In Y direction, if you want to resolve it, you take sin of theta. And in Y direction, there will be vertical component, or that is called also called as a Y component. We will consider Fy. Yes, suffix Y indicate the Y direction. Fy equal to F sin of theta. So this will be F sin of theta. So in this way, you have to resolve the given force F into two components, because we are discussing about the rectangular component. So X and Y direction. Okay. Similarly, if now here only one force is acting. Now suppose here another force is acting here, another force is acting here, another force is acting here. So at that particular time, you have to consider addition of all these forces, and that addition of forces is nothing but composition. Okay. Resolve and compose, these are the two important steps. So here we have discussed about a resolution. Resolve means split into components, and composition means what? Addition. Composition means addition. Okay. So here you can see you have to uh, resolve the compose the forces. Now this process, here we are adding the forces. Resolve means what? this F1 will be resolved into two components, in X direction, in Y direction. Okay, so this is F1. Now here I will just explain how to resolve this concurrent force system. You observe this particular diagram carefully. So here force system is concurrent at this particular point O. Okay, you can say it as O. All forces are passing through this particular point O. So here force F1 acting along its direction means its angle theta will be 0 degree with x axis, because this is x direction. From this origin x direction, this will be y direction, it will be minus x, this will be minus y. Okay, so the sign convention already know, this is minus y, above the axis this will be plus y plus x minus x, like this. So F1 is the force having 0 degree angle because it is exactly acting on the x direction. So this angle with the x axis will be 0. Second force, you can see this angle is given as theta 1. So when you will resolve F2 in x and y direction, this F2 will have two components, F2 cos of theta 2. Here you can say it as a theta 2 because force is F2, angle must be theta 2. Force is F3, angle must be theta 3. Force is F4, this angle must be theta 4. Force is F5, angle must be theta 5. You make these corrections. Okay. So, and now these are the five forces. We have to, as per the law, we have to calculate the resultant of this force system. There are five forces. Now I don't want five forces in the system. I want a single force which is the resultant of this force system. So what I will do? I will just add all these forces together. Okay. So taking their component called as a resolution means initially मैं क्या करूँगा उसको अभी resolve करूँगा. So F1 cos of theta 1, that will be the first force. This is F1, angle is 0. So F1 cos of theta 1 is 0 degree. Okay, F2 cos of theta 2. Okay, second force. This I will resolve like this. This is F3 cos of theta 3. F4. Why I have put here negative sign? Because this component will be resolved in x direction, negative. This will be in y direction. यहाँ पे x direction में resolve होगा, ये y direction में resolve होगा. So x will be negative. Here it is positive, negative. Here also it is negative. Okay. In this direction positive because to the right side of this will be positive x, to the left side of this negative x. Okay. So in this way what I will do here, I will add all these forces F1, F2, F3, F4, F5 by considering their angle of resolution with horizontal. Always you have to calculate this angle with horizontal. This is horizontal axis. So theta 1 to be measured with this x axis. Theta 2 also should be measured with this x axis. This theta 3 also should be measured with this x axis. Okay. So these are the angles. This force is F5, so this angle must be F5 here. It is not F3. So resolve this all the five forces, F1 cos of theta 1, F2 cos of theta 2, F3 cos of theta 3, F4 cos of theta 4 minus F5 cos of theta 5. But here this sign convention important. It is an important part of this particular problem because that sign convention indicates the component direction. So this is positive, positive. This is y direction positive, x direction. This one will be negative. This one will be negative. So here for F4 and F5, x component will be negative. So here you have to write minus F5 cos of theta 5. Similarly, in x direction, you have to calculate resolve the forces in y direction too. So summation in y direction, it will be F1 sine of theta 1. Yep. Y direction means what? This force you have to resolve into x and y parallel to this y, plus y downward to this minus y. So here F1 sine of theta 1 plus F2 sine of theta 2. For y direction you have to consider angle sine. So F2 sine of theta 2 positive, F3 sine of theta 3 positive, F4 sine of theta 4 positive, because this y direction component will be always positive. And here you can see if I resolve this x and y direction, as arrow is downward, so this y direction will be like this. This is towards negative y. So this fifth component I will write here minus F5 sine of theta 5. Okay. So in this way, after writing the forces in x direction, you have to add that, that is you have to take summation of fx. You add that component and write down summation of fx. Similarly, write down summation of fy. After getting two component of resultant fx and fy summation, you have to find out the composition procedure. Composition means what now? Adding these component together to get the resultant r. Then resultant r is equal to under root of summation of fx square plus summation of fy square. So we will get resultant r of the system. And after getting resultant R means this all the five forces will be resolved into only one single force, that may be R. Okay. So whatever R you will obtain, you can show this R here or here. That will depends upon the direction. How you will get the angle, accordingly you will get the location of this R. If summation fx is positive, fy is positive, means your R lies in first quadrant. If fx is negative, fy is positive, means R lies in second quadrant. If fx and fy both are negative, it shows that it will lies in third quadrant. So fx and fy here, summation of fx, summation fy are nothing but the component of resultant. कंपोनेंट के साइन कन्वेंशन का आपको देखना है कि यहाँ पे कौन सा पॉजिटिव कौन सा नेगेटिव है. अकॉर्डिंगली आर कैन बी लोकेटेड इन दिस क्वाड्रेंट सिस्टम and direction tan theta summation of fy upon fx. Sometimes you have to write down in modulus also, because when you will get the negative sign, at that time you must put it in modulus. But don't use the negative sign while calculating this angle. You just consider the numerical value here. So do not consider minus sign while calculating angle theta. And after getting this theta, theta is nothing but the direction of this resultant r. You can show this theta with the horizontal like this. This is the r and theta of the system. Means now in this system, instead of these five forces, if I replace this system by this system of r and theta, it is equivalent to this particular system. यानी कि इसका जो इफेक्ट होगा ये बॉडी पे और पार्टिकल पे सेम इफेक्ट will cause by this resultant. That is called as resultant of force system. So I have replaced these five forces by single force, that is called as a resultant force. I think you might have clear now idea of resultant. What is the role of resultant? So resultant is a single force which is equivalent to the number of forces acting in the system. Now we'll better understand through few numericals. So you can see the problem number 1 here. You can make correction. This is problem number 1 or 2. Just wait, I will go through this. Yes, I think that is problem number 2. Yes. Problem number 1 is this one. Okay, so this is problem 1. See here, what I have shown here, I have shown four forces. First one is a 15. I will start with first quadrant. This 15 kilonewton force, arrow is away. This angle I have taken 20 degree. Second force is 10 kilonewton. Third force is 30 kilonewton. Fourth force is 60 kilonewton. Okay. So here you can see, now I have to resolve these four forces into components. Sometimes you have to observe problem carefully and find out the angle of all the forces is horizontal before going for resolution. So before going for resolution, you find out the angle made by these forces with horizontal. Horizontal means what? This x-axis. This is positive x direction, this is negative x direction, this is positive y direction, this one positive y, and this will be negative y. Okay. So here, whenever you are going to add these forces into x direction, its component into x direction, first of all find out all these angles with horizontal x-axis and vertical y, with horizontal x-axis only. Because we are taking for x direction resolution, we are taking cos theta, and for y direction resolution, we are taking sin theta. So now I will resolve these forces into x component. So resolving forces into x component, that is summation of fx equal to. So first force is 15 cos of 20, because when I will resolve this 15 force, it will have two component. One is in x direction, another is in y direction. If I resolve it perpendicularly, okay, perpendicularly, what happened here? 15 cos of 20, 15 sin of 20, this will be the two component. But it is not a single force acting in the system, so that's why to avoid the confusion, so I will take a simple step to resolve it. So this will be the x component, and this will be the y component. Now see the sign convention. This is positive in positive x direction. This is positive because it is in positive y direction. So here I will add first component 15 cos of 20 in positive x direction, so positive. Second force is 10 kilonewton, but 10 is completely resolving in y direction. 10 का अगर मैं रिजोल्यूशन करता हूँ तो ये क्या है, completely y डायरेक्शन में, डायरेक्टली एक्सिस पे, तो x डायरेक्शन में रिजल्ट होगा क्या, नहीं होगा. अगर होता भी तो कैसे होगा, इट विल बी 10 cos of 90. ये कैसे होगा, बिकॉज दिस एंगल विथ हॉरिजॉन्टल एक्स एक्सिस विल बी 90. सो दिस 10 cos of 90, you know that cos 90 is 0, because cos 0 is 1, so cos 90 is 0. अगर आपको ऐड भी करना है तो आप कैसे ऐड करेंगे यहाँ पे इसको, 10 cos of 90, 10 cos of 90 and cos 90 will be 0. Okay, so cos 90 will be 0. So don't add that in x direction because cos 90 is 0. So this force will be 0 effect in x direction. Second one, third force. Third force is this, you can take this one because here in calculation I have taken this 60 first. So 60 will be resolved in x direction like this, this will be y direction. Because here arrow direction is like this, arrow के direction में force resolve होगा, this is y direction. So ये direction क्या होगा, positive x, and this direction will be negative y. So 60 कैसे ऐड होगा, 60 is the magnitude, angle is 50 degree, so 60 cos of 50 will be positive. The 60 cos of 50 will be positive, minus. Now why this 30 is taken as minus, because it will be resolved like this. Okay, so it will be minus 30 and it will be minus, it will be minus y. It will be minus because x direction is negative, here y direction is also negative. So it will be added in x direction 30 cos of 35. So this will be 30 cos of 35 and sign will be negative. Okay, sign will be negative. So in this way, this plus 0 means what? Here I have added this 10 cos of 90, that's why 0. Now intentionally here I have not shown the addition of all these forces because you should have practice on your calculator. That's why this is for your exercise. You add these forces by taking calculator and tell me this value. Okay, I will check it. Write down this answer. Similarly, resolve the forces in y direction. Resolve the forces in y direction. Summation of Fy. So y direction कौन सा होगा, ये y हो गया, ये y हो गया, ये y arrow will be downward, ये y arrow will be downward. These are the y component parallel to this y direction. So y, this plus 10 is exactly in y direction. So 10 sin of 90, sin 90 is 1. Okay, इसका एंगल क्या होगा, x axis से 90. So first component 10 sin 90, sin 90 will be 1. That's why I have not written over here sin 90. So it is 10 plus 15. ये y direction क्या होगा, positive, plus 15 sin of 20 minus this will be downward. So minus 60 sin of 50 and this will be downward, minus 30 sin of 35. So here I will get summation of Fy. Here we will get summation of Fx. Just like summation of Fx, you add all these components, write down summation of Fy here, and our main aim is to find out the magnitude of resultant. So r equal to under root of fx square plus fy square. Here you will get fx and fy. Also find their direction. Tan of theta equal to summation of fy upon fx, and it means that the theta equal to tan inverse of fy upon fx. You will get that angle. If see the directions of fx and fy, if fy is negative, fy is positive, then r will lie in second quadrant. You just see what are the sign convention of fx and fy. So in this way, you do these two calculations and tell me the value of fx, fy, resultant and its direction. Okay, so I will check it personally in the class. You solve this example and show me that answer, or try to cross check these values with your friend, no problem, but your calculation must be correct. So that is our aim. Okay, now see the next problem. Determine the resultant of the force system shown in figure. Now what figure is shown here? There is one crank arrangement is shown, or hook arrangement. Here three forces are acting. First one is 60 Newton, 120 Newton, 150 Newton. And if we extend the line of action of all these three forces, they will meet at this particular point. If I extend the line of action, they will meet at this point. And angle of resolution is also there. The 90 Newton force making an angle of 40 degree, 120 Newton making an angle of, but angle it is not 30 degree. We have to measure the angle with x axis. So very carefully here, many times your mistake happens. You are making mistake here. Angle between forces is given 30 degree. It means this 30 plus this 40 with horizontal, this angle will be 70 degree. For second force angle is 70. For first force angle is 40 because we are measuring these angles with horizontal. So here this angle is 35 of 150 kilonewton force. Now add these forces in x direction. So some resolving forces in x direction, summation of fx is equal to this et cos of 40. Okay, so this et cos of 40 in x direction positive plus this 120 cos of 40 plus 30 70. Yes, it is 120 cos of 70. It is in a, it will be also resolved in x direction. It will be also resolved in x direction like this. So these angles will be positive. And second one is minus 150. This will be minus because this is towards negative x direction. Minus 150 cos of 35. So in this way we will get Fx equal to minus 20.546 Newton. Similar to Fx. Now resolve these forces in y direction. In y direction you can see this. In y direction this force will be resolved in like this will be like this will be like this. Means all three forces are above this axis, they will be resolved in y direction, all will be positive. Means here sign convention of all the forces will be positive. So et cos of et sin of, yes, sin. So et sin of 40 plus 120 sin of 70. So 40 plus 30 70 plus 150 sin of 35. If we add this, we will get summation of Fy. After getting summation of Fx and summation of Fy, our next aim is to calculate the resultant of this force system. Magnitude of the resultant R will be equal to under root of summation of Fx square plus summation of Fy square. So by adding this, you will get the magnitude of resultant. And then find out its direction also. So tan theta equal to Fy upon Fx. So tan inverse theta equal to tan inverse upon Fy upon Fx. So here you ignore this negative sign. So here you can see for Fx there is a negative sign, but I have not taken that negative sign here. Okay. So in this way find out the magnitude and direction of resultant. So direction means what? Angle. So here you can see Fx is negative, Fy is positive, means your resultant R Fx negative. कहाँ पे होगा? Fy positive, Fx negative means second quadrant. Fx negative, Fy positive. So your R will lie in second quadrant. So your R will lie in second quadrant. So these three forces can be replaced by a single system like this. You can show in second quadrant. This is the magnitude of resultant R. So this will be the resultant magnitude, and angle is 85. This theta is 85. So this system can be replaced by this system just by showing R and theta in the second quadrant. This is called as finding out resultant of the force system. Now see the third problem. It is also like a previous problem. So one hook is shown here, okay, and three forces are acting. This one will meet here. Then second force, this will be also meet here. This will be also meet here. So all the three forces are meeting at this point. Now you have to resolve into component. So first force is this 60. Angle with horizontal is 25. Second force is this 40. Angle with horizontal is 60. Third force is 50 here. This one. And angle with vertical it is given as a 50. Here carefully, this is the mistake. It is not mistake, but you may make mistake here. Now see, with vertical this angle is given as a 50, means with horizontal this angle will be 40 degree. So here with horizontal you have to find out this angle as a 40 degree and then resolve. Okay, so summation of fx क्या होगा? This 60 cos of 25. Okay, x direction. Second one is this 40 cos of 60. This one. And third one minus 50 cos of 40. So this is minus, why minus? This component in x direction minus, and angle will be 40 degree, not 50. 50 is with vertical. Now here it can take cos 40. Add this, you will get summation of fx. Similarly, find out summation of fy. Now just consider forces in y direction. So this will be resolved in this way. Y direction positive. Here this y direction is negative. Here this y direction is negative. So first component will be positive, this one. So 60 sine of 25 upward positive minus 40 sine of 60 negative minus 50 sine of 40 negative. By adding this, we will get the value of summation of fx, summation of fy. Okay, and then find out the magnitude of resultant r under root of fx square plus fy square. We will get the resultant magnitude 54.93, and similarly find out the direction of this resultant tan theta equal to fy upon fx. So here ignore the negative sign, you just take numerical values 41.42 by 36.076. By solving it, we will get this angle theta, and see the sign convention of this force. Sign convention of this force, fy is negative, fx is positive. fx positive, fy negative. कहाँ पे मिलता है ऐसा? fx positive, fy negative. So if this is in fourth quadrant, normally try to draw the quadrant system. In quadrant system, your resultant will R will lie here. Fx is positive, Fy is negative, and show this magnitude here 54.93. Show this angle theta here 48.94. So here we will get the value of, here we get the location of resultant. So in this way, today we have solved 3 to 4 problems. Okay, on this particular resultant system. Now see the next problem. Here also this problem you can solve by using resultant or by using our skew resolution. In both the way you can solve this particular problem. You can see this problem. Two control rods are attached at A to the lever AB. Two control rods are there, F1 and F2. Okay. Knowing that force in the left hand of the rod F1 is 120. So this F1 is 120. Determine force F2 in the right side. If the resultant R of the force exerted by the rod is vertical. See this problem here, what is given here? R of the force system exerted by the rod on the lever is vertical. So R is given as a vertical. Resultant R is given as a vertical in this particular system. You have to find out F2. F2 is missing. So first of all here R is vertical, it means you know that component of the resultant are summation of Fx and summation of Fy. If R is vertical, it shows that resultant is not having X component, or component of resultant in X direction is 0 and component of resultant in Y direction is R. Okay. So resultant R is vertical, it means summation of Fx is 0 because X component of resultant is 0. When you will write fx here, fx is, you have to write down like this, fx is equal to 0 because component is vertical, so x component of resultant is 0. The resolve forces in x direction, कैसे होगा x direction resolution? So f2 cos of 10, this f2 cos of 10 minus f1 cos of 28 equal to fx, and what is that fx? Fx equal to 0. Here आप equal to, because it is fx equal to f2 cos of 10 minus f1 cos of 28 will be equal to 0 because fx equal to 0. Okay, so here we will get some relation f2 equal to, पहले equal to करके लिखो, ये sign positive हो जाएगा, and when you will write f2 equal to, it will be 120 because f1 is known, 120 cos of 28 divided by this will be on denominator here, you will get the magnitude of f2. Okay, and to find out the magnitude of R, you just take summation of Fy. We know that summation of Fy equal to R because it is given that R is vertical, means summation of Fy equal to R. Resolve these forces in Y direction. So here we will get this F2 sine of 10 with positive Y direction plus F1 sine of 28. F1 is 120 here and will be equal to R. Y direction में R है तो R भी उसमें आ जाएगा. Summation of Fy is nothing but R. Okay. By solving this, we will get the magnitude of R. Means by resolution, we have solved this particular problem. It can be solved by using non-perpendicular resolution also. That is also a simple method. So in this way, you should go through another few problem from your exercise problem, whatever question bank provided to you, and try to solve this particular type of problems. So today I will stop here. Thank you. Thank you very much.